Welcome back, everyone. We're going to do experiment 15.1, which is a demonstration of how to create a rainbow. Now, I have some supplies here, and I'm going to be following the instructions in the book, except that instead of having a flat pan, I'm going to have this, which is glass, just so you can see what's going on a little clearer. I also have a mirror. Instead of a sunny window, I'm going to attempt to do this with a flashlight. Now, first of all, I'm going to point something out which you won't really be able to see very clearly, but remember, and there is an experiment based on this where I would use a protractor and actually shine the light on something. It turns out that the angle of incidence, in other words, the angle that light strikes a surface, is going to be exactly equal to the angle of reflection. So I'm going to turn off all the lights in here for a second. All right. So if I take this flashlight, you can see there's a spot on the ceiling that's going to kind of give you an idea of what the angle of reflection is. So you see the flashlight, which is going to be, where my hand is, and take a look at the ceiling. Let's see, can I get this a little better? But anyway, when I make a wider angle of incidence, it becomes a wider angle of reflection, meaning that the spot of light on the ceiling moves back. If I make a narrower angle of incidence, I make a narrower angle of reflection. And there we go. And if we had a protractor like we're supposed to in the experiment, we could actually measure and see that the angles of incidence and the angles of reflection are identical. Now back to experiment 15.1. The reason that a rainbow occurs is because light will enter a water droplet, and remember that different colors will reflect and refract at different rates. So white light enters the water droplet, and then the different colors of light, and I'm not going to go to the trouble of actually drawing the different colors, are going to, because they're different wavelengths and frequencies, they're going to spread out. They're going to refract differently because they are different. And then they're going to hit the other side of the raindrop. And of course, some will refract out, but then some of it will be reflected back. And the different colors are represented by these different, it's all orange, but they're different, different little beams of light. And then they're going to come out the other side, and this is what actually causes a rainbow. The first thing we need to do in this experiment is take your container of what's going to contain water and add the water. So currently we have light shining in, just like in what I drew on the board a moment ago to create a rainbow. Light is shining in, and then it's going to hit, we can pretend this is like a raindrop. As light shines in, it refracts and then bounces off the bottom, reflects off again. Then at that point, like, it's going to refract as it leaves the water. So, and again, it's coming in at a certain angle of incidence and it's exiting at another angle of, or at an identical angle of incidence. Although in between it is bending, it's refracting as it goes from one medium to another. So then we're going to take this mirror just to make the reflection a little bit more pronounced. So I have now a submerged mirror. And if all goes well, I'm going to be able to shine this light on the mirror, and it's going to come in as white light, reflect, and refract off as a rainbow. Now you can see a little bit of reflection going on right now. Might be able to see some colors, but right now I'm just kind of seeing like blues and purples. Maybe I saw a little bit of green for a second. So I'm going to take a moment and mess with this, and once I really have this worked out, producing a good rainbowish result, then I will turn the video back on and show it to you. So I've been messing with this a bit, and the flashlight, first of all, was not enough light. So instead, shield your eyes for a moment, I'm using the floor lamp, which I've been using to light the room for all the videos. And still got this going on. And basically the way the experiment sets everything up, you have a light source, obviously this lamp, and then you have the light source reflecting off of your mirror, which is submerged, and then you reflect that back onto a white surface behind your light source. And you can see I'm doing that right now, or down below or above. Now I'm going to angle this camera and just know that that's what I'm doing. I don't think I can produce a really dramatic effect like a full-on rainbow, but I can at least demonstrate this a little bit. Hopefully it's worth the effort. Because, I don't know, I've never had a great history with this experiment. But I did notice something that was pretty clear. Maybe I can tilt this a little bit. Yeah, maybe. All right. And get that reflection right where the camera sees it. So you see that reflection, right? Now, note to self, is that pure white light? It is pure white light going in, and it may not be producing a rainbow, but what you see is a flicker of colors. And that flicker of colors, you have kind of a reddish, orangish, yellowish on the top, and then you have like kind of a bluish, violetish at the bottom. So while this isn't producing a rainbow, it is actually proving what we want to prove, which is that when light enters a medium, when white light enters a new medium, it's going to refract, and that the different wavelengths, as in Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet, are going to refract at different rates, meaning that they're going to separate out. And in the case of this experiment, as well as any time you see a rainbow, what's happening is a double refraction all the way across the sky. No, if you didn't get that reference, that's probably good. And so anyway, it's reflecting off of the mirror, just like it would reflect off of the back of a raindrop. So kind of step one, enter the medium of the water, refract, and then reflect back off the back of the raindrop is step number two. Step number three is then exit the front of the raindrop and refract again. So this double refraction we're seeing here is producing kind of a blue-purple side of this light blur, and sort of a red, orange-yellow side of this light blur. Hopefully you can see that clearly. I can in the camera. Alright, so we're going to wrap up this video by going over just some of the stuff that's going to be on the test for Module 15. And as you can see, I've got a wet shirt now. So, as usual, you're going to fill in blanks with the correct term based on the definitions provided, and those will be for the underlined terms. And there's not very many of them. I think it's just electromagnetic wave and the law of reflection. But if it's an underlined term, it's fair game. Be able to describe how light works. Is it a particle? Is it a wave? Go into detail, it says in the test. And so that'll be kind of the beginning section of the module. Understand the different speeds of light as they go through different substances. That'll be important. And with that, actually be able to pretty much duplicate image figure 15.6. Oh, there we go. Image 15.6. Understand that one real well. Figure 15.6 is what it's called, sorry. And in kind of a similar vein, in the study guide at the end of the module, be sure that you can do problem 15.7 really well. Now, they're going to ask you questions about different frequencies of types of waves, like, for example, radio waves, TV waves, microwaves, gamma rays. And be able to know which ones have longer or shorter wavelengths and higher or lower frequencies. Know the same thing for the colors. For example, does red or purple have a longer wavelength? Which one has a higher frequency? Things like that. Now, also know how concave and convex lenses, that's actually terms that I originally learned from them. In the book, they're called converging and diverging lenses. Know how they work and when to use them. Understand how the eye changes its focal point. Understand how the eye works with the ciliary muscles and the lens and creating a focal point on the retina. All of that stuff. Understand how to mix colors of light as well as colors of paint. In other words, the additive primary colors and the secondary primary colors and how they work depending on whether you're mixing light or paint. One of the harder ones, it's going to ask you if you have an object of a certain color and you shine a light of a certain color on it, not white light, but another one, then what's going to be reflected? So I believe there's either an on your own question or something in the chapter review that's very similar to that. So be sure that you're comfortable with that type of a question. And I think that's about it. So study hard, do well, and I will be receiving your tests by email. Let me know if you have any questions, concerns, etc. And thank you for watching.